Most students feel JAMB Physics not because it's hard, but because they don't practice the right questions. If you're writing JAMB 2026, this video can change your score. I'll be solving real JAMB style physics questions, step by step in a simple way anyone can understand. Whether you're aiming for engineering, medicine, pharmacy, or any science course, stay focused, this one is for you. And make sure you join my WhatsApp channel for daily updates. The link is on the comment section. Let's get started. The first question we have for today says, a person sitting in a closed room hears someone talking in the hallway. This is possible because the sound waves can bend around corners. This bending of waves is called dash. A. Reflection. B. Refraction. C. Diffraction. And D. Refraction. Now, first things first, we're going to define each of these key terms. When we're done with that, we'll pick the correct answer. The first term there is reflection. In physics, reflection is the change in direction of a wave when it strikes the boundary of two different media, causing it to return to the original medium. That is what reflection is all about. The next term we have is refraction. Refraction is the bending or change in direction of a wave. These waves can be light wave, sound wave, or water wave as it passes from one medium to another, caused by a change in the wave speed due to the different densities or properties of the material. The next we have, which is option C, diffraction. It is the bending and spreading of waves such as light, sound, or water waves as they pass through obstacles or through openings. These waves tend to divert, like when they pass through a particular opening or an obstacle. That phenomenon is called diffraction. Option D, rarefaction. It is a decrease in density, pressure, or particles of a medium. Please take note of all these key terms I'm defining. Rarefaction is a decrease in density, pressure, or particles of a medium. The correct answer here is option C, diffraction. Diffraction is the scientific word for waves bending or spreading out when they pass through a narrow opening, like a doorway, or they go around an edge, like a wall corner. That is why you can hear someone speaking in the next room, even if you can't see them. The sound waves hugs the corner and spread into your room. So the correct option there is option C, diffraction. Now, question 2 is a very technical question, and this is a typical JAMB question. This is how JAMB set their questions. It says, which of the following happens to the density of a substance if it is heated and it expands? Which of the following happens to the density of a substance if it is heated and it expands? A. The density increases. B. The density decreases. C. The density stays the same. And D. The density becomes zero. Now, first things first, we're going to define the concept of density. Density is a measure of how tightly packed the mass is inside an object. Now, when you heat most objects or most things, they expand, meaning the same amount of stuff now takes up more space or volume because the particles are now spread out further apart. The substance becomes less dense. So the correct option there is what? Option B, the density decreases. Please note that when you heat an object or a substance and it expands, the density decreases. The third question is very technical, so you need to pay attention. It says, why do passengers in a fast-moving car jerk forward when the driver suddenly applies the brake? Why do passengers in a fast-moving car jerk forward when the driver suddenly applies the brakes? A. Because of the friction between the tires. B. Because of the force of the engine. C. Because of the principle of inertia. And D. Because of the gravity of the earth. The correct answer here is option C, because of the principle of inertia. Now, what is inertia? Inertia is the property of a matter that makes it lazy. It is the first law of Newton, also known as the law of inertia. It states that an object at rest will remain at rest, and an object in motion will continue at a constant velocity unless an external force acts upon it. Inertia is the tendency of an object to resist changes in their state of motion. That's what inertia is all about. If an object is moving, it wants to keep moving. When the car is moving, your body is also moving at that speed. Your body is moving at the speed of the car. When the car stops suddenly, your body, due to inertia, tries to keep moving forward at the old speed, which causes the jerk. So the correct option there is option C, because of the principle of inertia. Question 4 is a bonus question, so please take note. It says, in a simple machine like a lever or a pulley, what is the term for the point where the machine pivots or turns? In a simple machine like a lever or a pulley, what is the term for the point where the machine pivots or turns? Option A, the load, B, the effort, C, the fulcrum, and D, the mechanical advantage. Okay, let's explain. Now think of it as a seesaw. The load is the person you are trying to lift. The effort is the force you use to push down, and the fulcrum is the fixed support or turning point in the middle that stays still while everything else rotates around it. So the correct option there is option C, the fulcrum. That is the point where the machine pivots or turns. Option C is the correct answer, the fulcrum. Question 5 is very common, and then it's common among ladies. It says, which of the following is the reason why a person wearing high-heeled shoes exerts more pressure on the ground than a person wearing flat shoes? Women can relate, girls can relate to this particular question. Option A, high-heeled shoes are heavier. B, the level of the heel is very small. C, the person is walking faster. And D, the flat shoes have more friction. The correct option there is option B, the area of the heel is very small. Now note that pressure is the force divided by area. Pressure is P equal to F over A. That's the mathematical expression of pressure, the force acting per unit area. This means that if you put the same weight, which is force, on a very small area like a sharp heel, the pressure becomes very high. Now, if you spread the same weight over a large area, let's say a flat sneakers, the pressure on the ground is low. This is the reason why a sharp knife cuts better than a blunt one. So don't forget, the correct answer there is option B, the area of the heel is very small. That is why a person wearing a high heel shoe exerts more pressure on the ground than a person wearing flat shoes. So we move on to the next question, which is question 6. Now question 6 says, which of these properties of a wave remains the same when light travels from air into a glass block? Which of these properties of a wave remain the same when light travels from air into a glass block? Option A, speed, B, wavelength, C, direction, and D, frequency. Now, the correct option to this question is option D, frequency. When a wave, either light or sound wave, moves from one material to another, it usually changes speed and its wavelength changes. However, the frequency, which is the number of vibrations per second, take note that frequency is the number of vibrations per second. The frequency is determined by the source that created the wave. Once the wave is born, its frequency never changes. So no matter what material it passes through, the frequency remains the same. Hence, the property of a wave that remains the same when light travels from air into a glass block is the frequency. Now we are here at question 7, but please, if you have not liked this video, don't forget to like, share with friends, and leave a comment. Question 7 says, an echo is a sound that returns to the sender after it hits a wall. This is a result of dash. An echo is a sound that returns to the sender after it hits a wall. This is a result of dash. A, refraction of sound. B, reflection of sound. C, absorption of sound. And D, interference of sound. The correct option here is option B, reflection of sound. Reflection is simply a wave bouncing back after it hits a surface. That's what reflection is all about. A wave bouncing back after it hits a surface. Think of it as a football. When you play a ball to the wall, it bounces back. That's what reflection is all about. This is the same thing as the way a mirror reflects light so you can see your face. A hard wall reflects sound waves so you can hear your own voice a second time. We call this reflected sound an echo. That's what an echo is all about. So the correct option there is option B, reflection of sound. Now a quick one. Question A says, if you place a compass near a wire carrying a large electric current, the compass needle moves. This shows that A, electricity is the same as gravity. B, an electric field current creates a magnetic field. C, the wire is made up of permanent magnets. And D, the battery is leaking energy. The correct option there is option B, an electric current creates a magnetic field. This is a discovery made by Hans Ørsted. Whenever electric flows through a wire, it creates an invisible magnetic force around that wire. A compass needle is a small magnet, so it reacts to the magnetic field created by the electricity in the wire. This is the basic principle behind how electric motor works. Please note that it doesn't show that electricity is the same thing as gravity. It doesn't show that the wire is made up of a permanent magnet and that the battery is leaking energy. These options are wrong. The correct option is option B. Now look at this question. It says, why are the bottom of dams built to be much more thicker than the top? Why are the bottoms of dams built to be much more thicker than the top? Option A, to save money on building materials. B, because water pressure increases as you go deeper. C, to prevent fish from eating the walls. That's very funny. And D, because the top of the dam is more important. These options are wrong except option B. The correct option there is option B, because water pressure increases as you go deeper. Option A, to save money on building material, wrong. To prevent fish from eating the walls, wrong. Because the top of the dam is more important, is also wrong. In a liquid, the deeper you go, the more weight of water is sitting on top of you. This weight creates what they call pressure at the bottom of the dam. The water pressure is huge compared to the surface. Engineers build the bottom of the dam thicker and stronger so it doesn't break under that heavy pressure. That is the reason why the bottom of dams are built to be much more thicker than the top. Oh, question 10, the final question for today. Please, if you have watched this video to this point, do clap for yourself. You have tried a lot. Question 10 says, what type of mirror is commonly used by dentists to see a larger, in bracket, magnified image of a patient's tooth? What type of mirror is commonly used by dentists to see a larger magnified image of a patient's tooth? A, plane mirrors. B, convex mirrors. C, concave mirrors. And D, translucent mirrors. Now I'll explain each of this type of mirrors so we can understand them better. The first we have there is the plane mirrors. This is a flat, smooth surface that reflects light evenly. The images are virtual, upright, and same size as the object, but reversed left to right. It is used in bedroom mirrors, dressing mirrors, and periscopes. We also have the next, which is the convex mirrors. The convex mirrors, they curve outward like the back of a spoon, causing a parallel right rays to spread out, diverging. Now the image is always virtual, upright, and smaller than the object, providing a wider field of view. It is used in image vehicles like the side mirrors of cars and security mirrors in stores. The third option we have there, which is the concave mirror. The concave mirror, it curves inside, it curves inward like the inside of a spoon. Take note, the convex mirror curves outward while the concave mirror curves inward like the inside of a spoon, focusing parallel light rays to the focal points. The image can be real, inverted, magnified or diminished, or virtual. It can be upright and magnified depending on the object distance. Example of where you can find this kind of mirror is in shaving or makeup stores. Yeah, all those places you go to makeup, that's where you find this kind of mirrors, car headlights, and telescopes. The fourth option there, which is translucent materials. Note, this is materials and not mirrors. Translucent are materials and not mirror. There's no mirror like translucent mirror. So these are materials like frosted glasses or thin paper that allows light to pass through but scatter it, preventing clear image. So now we have known the types of mirror and their meaning. Let's answer the question. The correct option there is option C, concave mirror. It curves inward like a cave, as I said earlier, and has special properties. If you put an object very close to it, it creates an image that is upright and much larger than the real object. Dentists use this to get a zoom in or clear view of small parts of the teeth. So the correct option there is option C. If this physics question made sense to you, then you're on the right track for 2026 JAMB. Drop a comment now and tell me the course you're going for: engineering, medicine, pharmacy, or any other course. Don't forget to like, subscribe, and share this video with some serious JAMB bites. For daily JAMB question, updates, and last minute tip, join my WhatsApp channel. Just click the link in the comment section. See you in the next one. Bye.